All right, we're going to do chapter 4. Chapter 4 is stoichiometry. Stoichiometry is going to relate how much. How much of something do we need to make something else? So how many grams or how many cups of flour do you need to mix with a certain amount of sugar to make some cookies? It really is taking our recipe, which is our balanced equation, and figuring out how much. Because we have to work in the lab, we know our how much is almost always going to be in units of grams, but we know that our recipe, our balanced equation, is always in units of moles. So step 1 is always going to be balancing our equation. So let's imagine that we have hydrogen plus nitrogen is going to make some ammonias. So the first thing I did over here was I got rid of the odd and even issue with 2 ammonias, 2 nitrogens here. I put a 2 nitrogen there. That leaves us with 3 hydrogens over here and a nice balanced equation. Realizing what these stoichiometric coefficients tell us. This is moles. We have 3 moles of hydrogen for every 1 mole of nitrogen for every 2 moles of ammonia. That's step 1. Our step 1 is to make sure we can see our mole relationships or our mole ratios or our stoichiometric ratios. We're going to call them mole ratios because that's the easiest. If we want to know how many grams, that's going to be straightforward because if we've got moles and molar mass, we can always get grams. So with that. So what do? Step 1, write the balanced chemical equation. Step 2, figure out how many moles of what you have because you're always going to be given something. Given a certain amount, how much something else do you need? So we're going to start out with that given amount and we're going to have to convert to moles. Why? Because the units in our balanced equation are in moles. We're then going to use our coefficients in the balanced equations, which are mole ratios, to go from what we have into what we need. And the last thing we're going to do is we're going to finish the problem. If it's going to be grams, we're going to use molar mass. If it's going to be molarity, we're going to use volume and our moles to get a molarity. So it depends on what we have for what we finish. But either way, step 1, balanced equation. Step 2, moles of what you have. Step 3, use the mole ratio to get moles of what you need. Finish the problem. So we have aluminum powder is reacting with iodine, and we know iodine is one of the diatomics that we have to take and write as an I2, and it's going to react and make solid aluminum iodide. Now we know aluminum's in group 3, therefore it has a +3 charge. Iodine is in group 7, so it's going to be a -1. So our formula for aluminum iodide is Ali3. Step 1, write the balanced equation. Aluminum plus iodine goes into aluminum iodide. Now, again, this has the odd and the even issue. The iodine is a 2 and this is a 3, so we're going to put a 2 here, which gets rid of the odd and even, giving us 6 iodines, so we need 3 here. So we have 6 on both sides and 2 aluminums. If we complete this correctly, we're going to put in solids, because we're going to make solid compounds. Aluminum iodide outside of water is going to be a nice solid. All right, so we have our balanced equation. So with our balanced equation, where we have 2 aluminums plus 3 iodines goes into 2 aluminum iodides. Because we have our balanced equation, we can take and we can consider how many moles we might need of something, as well as how many grams. So let's start from the basics. Moles of aluminum iodide. So we're going to start out with 4.5 moles of aluminum. That's our starting material. If we want to go from 4.5 moles of aluminum into aluminum iodide, we want to go and use the balanced equation because the balanced equation gives us the mole ratio. The ratio between aluminum iodide and aluminum is 2 to 2. So we have 2 mole of aluminum iodide for every 2 moles of aluminum, and we're going to make 4.5 moles of aluminum iodide. All right, so far straightforward. Now, we're going to start instead on this question with 8 moles of aluminum. And instead of asking ourselves how much aluminum iodide, we're going to ask ourselves how much iodine do we need? Well, our mole ratio is our conversion factor. in units of moles. And we're going to go to our balanced equation from our first step here and get our ratio. The ratio of iodine to aluminum is 3 moles of iodine to 1 mole of aluminum, or excuse me, 2 moles of aluminum. So we're going to write 3 mole of iodine for every 2 mole of aluminum. And we're going to do our math here and realize that 8 divided by 2 is 4. So we're going to need 12 moles of iodine to react with 8 moles of aluminum. So take it one last step. Instead of asking ourselves mole to mole, and mole to mole is just going to use our balanced relationship or our balanced equation, we're going to do grams. In order to do this, we're going to have to do step 1, balance our equation. So let's verify, and we know it's balanced. 2 aluminum plus 3 iodine goes into 2 aluminum iodide. That's step 1. If we want to go and relate these two, and relating iodine to aluminum, and we still know that we have 3 moles of iodine for every 2 mole of aluminum. In order to get there and go from moles of aluminum to moles of iodine, we have to get moles of aluminum first. So step 1, balance the equation. Step 2, moles of what you have. Well, what we have is aluminum. So if I have 54 grams of aluminum, if I want to go from grams into moles, I know I'm going to take and divide by the molar mass. So 54 grams divided by 27 grams per mole is going to give us 2 moles of aluminum. I have 2 moles of aluminum. I need to go from moles of what I have to moles of what I need. Moles of what I need are going to be our starting amount, which is 2 moles of aluminum, multiplied by our ratio over here, 3 mole of iodine for every 2 mole of aluminum, giving us 3 moles of iodine. Now, we don't want moles, we want grams. In order to go from moles into grams, we have to multiply by the molar mass. So we're going to look up the molar mass of iodine and realize that's 254 grams per mole. And if we take 254 grams per mole and multiply it by our 3 moles of aluminum, we're going to get a total here of 508 grams of iodine. So 3 moles of iodine multiplied by the molar mass, 254 grams per mole, is going to give us our mass of iodine we need to react with 54 grams of aluminum. Continuing, and we're just going to keep practicing until this makes sense. Step 1, balance. And we have to balance because that's going to give us our mole ratio. So if we're going to take a look at this one, we're going to have to deal with the fact that we're going to start out and do odd and even numbers. So let's start with at least somewhat the obvious. 1 carbon, 1 carbon. 4 hydrogens. If I put a 2 here, I'm going to get 4 hydrogens. That's great. Now we got oxygens. Well, on this side, we have 4 oxygens, 2 here and 2 here. And on this side, we have 3, which immediately gives us the odd even problem. So we're going to multiply this entire mess through by 2. So I'm going to have 2 ethanols. I haven't balanced the oxygen yet, so I'm going to leave it blank. It's going to go into 2 CO2s plus 4 H2Os. And now I can count and see how much oxygen I need. On this side, I've got 4 plus 4 for a total of 8 oxygen. Here I've got 2 oxygen, so the remaining 6 has to be here, and I'm going to put a 3. And I've got a balanced equation. So, step 1, balance. Now we're just going to go straight from moles to moles. We know if we go from moles of one into moles of the other, we just use our balanced equation. So if I have 3 moles of methanol are used up in the combustion, how many moles of water will be produced? Well, I know my ratio here is 4 moles of water for every 2 moles of methanol. And if I divide this through here by 2, I'm going to get a total of 6 moles of water. I'm going to make twice as much water in terms of moles as the amount of methanol that I begin with. So That's going to be our moles. Now, if I instead want to do grams, I know that I'm going to have to start one. It's the equation. If I want grams of something, I know I still have to work through this moles in the middle. We know we have to work through the relationship of CO2 to methanol. We know there's 2 moles of methanol from our balanced equation for every 2 moles of carbon dioxide. So in order to use that ratio here, I've got to go from grams first. Well, we know to go from grams of CO2 into moles, we're going to divide by the molar mass. So we're going to take our 88 grams. It's a little cleaner if we take and put it like this and put 1 mole on the top, and the molar mass of carbon dioxide is 44 grams per mole, giving us a total of 2 moles of carbon dioxide. So step 1, balance your equation. Step 2, moles of what you have. Step 3, moles of what you need. Go to your balance relationship and take 2 moles of methanol for every 2 moles of carbon dioxide. I only need those 2 portions because I'm comparing carbon dioxide to methanol. We're ignoring the oxygen and the water in this equation, giving us 2 moles of methanol. If I want grams of methanol, I know I'm going to have to multiply by the molar mass of methanol. So I'm going to take my 2 moles of methanol, calculate the molar mass. The molar mass of methanol is 32 grams per mole. And I'm going to get a total of 64 grams of methanol that I need to make 88 grams of carbon dioxide. Continuing, we're just going to do a different combustion question. And again, it's not going to change. We're going to have to balance the reaction. Moles what we have, moles are what we need, and finish the equation. So if we take a look at this, I got 6 carbons, so I'm going to need 6 carbon dioxide. I've got 6 hydrogens. 6 divided by 2 is 3 waters. I'm then going to look at this and realize that I have an even number of oxygens here and an odd number here. So the first thing I'm going to have to do is multiply the entire thing through by 2, and we're going to get 2 benzenes reacting with oxygen. We'll balance in a minute to make 12 carbon dioxides plus 6 waters. If we count up our oxygen, we have 24 plus 6 oxygen for a total of 30. 30 divided by 2 is 15. And we've got a balanced equation. So step 1, balance our equation. We know that we are going to compare carbon dioxide with oxygen. From our balanced equation, we have 12 moles of CO2 for every 15 moles of oxygen. In order to get moles from the grams of oxygen, I have to use the molar mass. So let's start with this. 21 grams of oxygen. When we do this and we divide through, again, we're just going to put that 32. Don't forget there's 2 oxygens there. Grams per mole of oxygen. I'm going to get a total here of 0.656 mole of oxygen. From our balanced equation, we know there's 12 moles of carbon dioxide for every 15 moles of oxygen. You can, at any point in time you want, combine all of these steps and do it in one clean line. I'm breaking apart for no particularly good reason. This is going to give me 0.525 mole of carbon dioxide. If I have 0.525 mole of carbon dioxide, I'm going to multiply by the molar mass. We know to go from moles to grams, we multiply by molar mass. So I'm going to multiply by 44 grams per mole. And when I do that, I'm going to get 23.1 grams of carbon dioxide. Nothing changing. 1, balance. 2, moles of what you have. 3, moles of what you need. 4, finish the problem. All right, how many moles and grams of our dibromoethane are we going to make from the reaction of this number of grams of ethene excess bromine? So step 1, C2H4, I'm just going to combine and write the formula. is reacting with bromine to make C2H4Br2. And it is conveniently balanced. So 1 balanced, 2 moles of what we have. We have 12.85 grams of C2H4. We know we're going to divide by the molar mass to get the number of moles of this. So if I have 1 mole of C2H4 for every 28 grams of it, I'm going to get a total here. Well, I skipped that step. So let me do that quickly. 12.8 divided by 28 is going to give me 0.459 mole of C2H4. Moles of what we have. Let's go into moles of what we need. Our relationship here is 1 to 1. I have 1 mole of my product, C2H4Br2, for every 1 mole of C2H4, and that's going to give me 0.459 mole of my product. My last step is mass, meaning I need the grams. In order to do this, I need to go to the periodic table and realize that I have 187.8 grams of C2H4Br2 for every 1 mole of it. And I'm going to take my moles, I'm going to multiply by the molar mass, and I'm going to get a total of 86.2 grams of my product. Now, we can do the same thing using molarity rather than molar mass. So let's think about this for a moment. We know that if we need to go from grams into moles, we're going to divide by molar mass. If we're going to go from moles into grams, we're going to multiply by molar mass. And we can use volume and molarity because we know that the volume in liters multiplied by the molarity going to give us moles. So we need to keep track of those 3 options when we take and do these calculations. So if I have a volume of something and I need moles, I have to put the volume in liters, and I'm going to have to multiply by the molarity. So with that in mind, if I have 43.8 mils of 0.107 molar HCl and it's going to neutralize, nice acid-base neutralization, 37.6 mils of barium hydroxide. So I've got volumes and molarities. What is the molarity of the barium hydroxide? Step 1, balance it. I've got 2 OHs, so I need 2 HCl's, which means I'm going to make 2 H2O's. Balance is reacted. My reaction is balanced. Step 1. Now, step 2, moles of what I have. Well, I have HCl. I know that volume in liters multiplied by my molarity is moles. And I know I can convert this because if I have 43.8 milliliters, I know there's 1 liter for every 1,000 mils. And that's going to give us 0.0438 milliliters. Excuse me, 0.0438 liters. So here we go. 0.0438 liters multiplied by 0.107 molar. And remember that molar is mole per liter. This is of HCl. Is going to give us the number of moles of HCl, and that's going to be 0.00469 mole of HCl. That's moles of what I have. Well, what I need is barium hydroxide. So I'm going to go to my balanced equation. My balanced equation says 1 to 2. And I have 1 mole of barium hydroxide for every 2 mole of HCl. So if I do this, I'm going to end up with 0.00234 mole of barium hydroxide. And we know that the volume in liters multiplied by the molarity is moles, so that the molarity is going to equal moles divided by the volume in liters. If I have 37.6 milliliters, I'm going to divide by 1,000, and I'm going to get 0.0369 0.0076 liters. So 0.00234 mole of barium hydroxide divided by 0.0376 liters. Again, molarity is moles per liter. Going to give us the molarity of this solution, and that's going to be 0.0623 molar barium hydroxide. So this is the last example, and this combines all of it in that we need a balanced equation. We're going to get moles of what we have, moles of what we need, and because we need mass, we're going to need molar mass, and because we have volume and molarity, we're going to have to remember that the volume in liters multiplied by the molarity moles. So with all of this in mind, let's start with lead chloride. It's going to be precipitated. Now note, this can be precipitated, which means this is going to be our product. And we're going to make lead chloride as a solid. We are going to make it from the reaction of, so this is our starting material. Our starting material is sodium chloride plus lead nitrate. We have to have the right formulas, otherwise this goes to pieces fast. And those are our formulas. Our other product, which isn't listed, but you should be able to figure it out, is going to be our sodium nitrate. We have to balance this. Note we have 2 chlorides, so we need 2 chlorides. So we're going to have 2 sodium nitrates over here. And we've got a balanced equation. We have over here 150 mils. We know that's 0.150 liters. Remember, divide by 1,000 of 0.250 molar of our sodium chloride. So step 1, balance. Step 2, moles of what we have. So if I want moles of this, I'm going to take 0.150 liters multiplied by 0.250 molar of sodium chloride, and I'm going to get the number of moles of this as 0.0375 mole of NaCl. Moles of what I have. What I need are grams of lead chloride. Well, for my balanced equation, I know I have 1 mole of lead chloride for every 2 moles of sodium chloride. So I'm going to divide through here by 2, and I'm going to get 0.0188 mole of lead chloride. Now, I'm asked for mass. To get grams, we know we have to take moles multiplied by molar mass. So we need the molar mass of lead chloride. We add up our lead and 2 chlorides, we're going to get a molar mass here of 278.1 grams per mole. So we're going to take 0.0188 mole of lead chloride. We're going to multiply this by 278.1 grams per mole for a total here of 5.23 grams of lead chloride.